A relation is simply any set of ordered pairs. It could be numbers, like a point on a graph, right, has an x and a y part that's an ordered pair, okay? So it could be like the point 2, 3. So the x is the 2, the y is the 3. Or it could be something as simple as a person's name and their hair color. That's an ordered pair because it has their name and their hair color, 2 things, right? So the domain is always the first components, okay? Or the x values or the input. Okay, so the domain is the x values or the first component of that pair, or sometimes we call that the input. The range is all the second components or the y values or the output. All things we refer to the range. So here I have an example of a relation. It's a set, and we have 1, 2, 3, 4, 5 ordered pairs, each with an x and a y value. Right? So you're the first component and the second component. There's a comma in between them. So the domain will be the set of all the x components or the x values. Jacob, what's one number that should be in my domain? 0. It's one of the x values here. Nina, what's another number that should be in my domain? 10. That's the x component here. Bella, what's another number that should be in my domain? Any of the other x values. Sorry, I know you're still writing. I rushed you on that one. Oh. 20 would work. And then we also have 30 and 40. So those should all be my domain, all the x components or the first component. Then my range will be all of the y values. So that's going to be 9.1, 6.7, 10.7, 13.2, and 21.2. So any relation is an ordered pair, right? Any amount of ordered pairs. There could be 20 ordered pairs. There could be 5 ordered pairs. There could be an infinite number of ordered pairs. The domain will be all the first part of the ordered pair or the x values, and the range will be all of the y values, okay? A function is a special kind of relation. A function is a relation where each member of the domain corresponds to exactly one member of the range. Or in more simple terms, the x value cannot repeat. So no repeats in the domain. The more fancy definition makes a lot more sense when you're looking at a graph. So, but no repeats in the domain. So every x value only has one y value assigned to it. That's what that first sentence says. Okay? So I want you to look at A and B here. These are 2 relations. Each of them has 4 pairs in it. And I want you to look at it and decide if you think it's a function or not. And write underneath it, function or not function. Ask yourself, are there any repeats in the domain or the x values? If there's a repeat in the x value, it's not a function. If there are no repeats in the x value, then it is a function. What do we think about A? Is this a function? Yeah, we've got our domain as 1, 2, 3, and 4. Are there any repeats there in the domain? No, there's a repeat in the range, but that's okay, right? It's just repeats in the range. So this is a function. How about B? Is B a function? No, what's repeating? 6. The 6 in the domain is repeating, so this is not a function. It's a relation still, right? There's still a bunch of ordered pairs, but it's not a function. So now it asks us to write the domain and range. So the domain of A, the relation in A, is all of the x values, 1, 2, 3, and 4. The range is all the y values, 6, 8, and 9. I don't repeat the 6 in the range because when 6 is in this set, that just means it's in the range, right? So when you put a number in a set, you don't repeat it twice, right? Because it's either in that set or not in that set. And if 6 is in that set, then it's a part of the range. Even though it happens in the range twice, you don't need to list it twice in the set. So go ahead and write down the domain and range for B on your own. Bianca, do you want to tell us what you got for the domain? Yep, 6, 8, and 9. We don't need to repeat the 6 twice because it's either in the domain or not. We don't need to say that it's not going to be in there. We don't list it as in there twice. Salvador, did you get the range? Did you write that down? What did you put for that?
1, 2, 3, and 4.
Yeah, 1, 2, 3, and 4. All the y values. Okay, so domain and range. Domain X, range Y. We kind of remember that a little bit at least, right? Domain is X values, range is Y values. These sets only have like a few things in them, right? We listed out all the ordered pairs. This is not what usually happens in math, right? We don't usually have a list of all the ordered pairs, okay? These are nice and pretty because there's only like 5 or 4 things in them, right? Usually our relations and functions have infinite things in them. So we don't list them out, okay? For example, this right here, oops, sorry, hold on one sec. If we draw the graph, of this equation right here, this looks like this, okay? This is a relation because every point on this graph has an ordered pair, an x coordinate and a y coordinate, right? And we describe it with an equation because there are an infinite number of points on this graph, right? And you cannot list out every single ordered pair that's on that graph. And that's exactly what an equation is. It's a way to describe the relation, right? All the set of ordered pairs without having to write out all 500 bajillion, 800 million, infinite amount of pairs that are on that graph, right? That's what a equation does, okay? So most of the time, our relations we see like this as an equation, okay? Or a function. So in this case, when we have an equation, we have to think a little bit differently about whether it's a function because we don't see whether there's any repeating x values, right? We don't have a list of all of the ordered pairs. So there's 2 ways you can determine if an equation is y is a function of x. One, you can try to solve for y. That's one way to see if y is a function of x. Or you can look for patterns. You will probably decide you want to look for patterns, but I'm going to show you both ways so that you can kind of understand why the pattern is what it is. So we're trying to see if this equation is a function. So we're looking for no repeats in x values, but we don't have a list of ordered pairs, right? So we have to figure out how to figure out if this is a function. So if you were to take this equation and solve for y, you could subtract x squared from both sides. And you would get y equals 4 minus x squared. So for this situation, we were able to solve for y. Y is by itself, right? So we did that successfully. And this means that no matter what x I put in, there will only be one y that comes out, right? There's not going to be another y, a different y that comes out. So that means there's not going to be any repeats in the domain, okay? A repeat in the domain means for 2 x's, you have 2 different y values, right? So this is going to be a function because I was able to solve for y any x I put in there, it's going to give me out a single y value, right? So it's not going to, I'm not going to have two possible outputs for the same input. So that is a function. Whereas over here for b, if I try to solve for y, I can still subtract x squared first. And then I'll have y squared is equal to 4 minus x squared. Y is not yet by itself. What would I have to do to get y by itself? I'd have to square root both sides, but do you remember what you have to put in front of it whenever there's a square root? Plus or minus, and this is where the issue comes in. Because the second I put that plus or minus in front, this means now I have two equations. The positive 4 minus x squared and a negative 4 minus x squared under the radical. So now, if I were to pick one x value like 2 and plug it in, I'm going to have two different answers, right? And that's not a function, right? That's going to be two x values that have or one x value that has two different y values, okay? So this would be a situation where the x values do repeat, because when something weird happens when we solve for y, and we now have two possible answers for every x that we plug in, okay? And so this one is not a function. Now, solving for that wasn't miserable, okay? But it's also not the easiest thing in the world. So another way to decide that that's not a function is to look at patterns, okay? What do you notice is the only difference between these two equations at the very beginning? What's the only difference? The y is squared. The y is squared on the one that's not a function, and the y is not squared on the one that is, right? The x is squared on both, and that didn't seem to cause a problem because it was squared over here, and it was still a function. So if you see y squared anywhere, you know it's not going to be a function, okay? Because if you solve, at some point you're going to take the square root of both sides, you're going to get that plus or minus. Okay, so if you see y squared, you know it's not going to be a function. Now, we could have other powers of y in reality. We could have a y cubed, okay? A y cubed is actually going to be okay. It will still be a function if it's y cubed, because if you do the cube root of both sides, you actually don't have to put a plus or minus in front of a cube root. It's only a square root, which is kind of weird. If you have y to the fourth power, that's also going to be a problem because you have to put a plus or minus in front when you do a fourth root, okay? So in reality, the stuff that's going to cause problems is when the y has an even power. We don't see much. 2 is the most common even power we see. We don't see y to the fourth very often, right? Or x to the fourth very often, okay? But the x can be whatever power it wants, right? There's no problems. X power doesn't matter. Okay, it's just the y that you need to focus on, okay? So if you want to look for patterns, you're going to look for if the y has an even power, then it's not a function. You can also try to solve if you want, right? But really what we're looking at is when y has an even power, that's when we're going to end up with those two separate equations. So you can just look for that pattern instead of having to solve. Does that kind of make sense? How that pattern would help you do it faster? Any questions about that? So we looked at the ordered pairs and we said it's not a function if there's a repeat in the x value, right? When you have an equation, how do we figure that out? Well, you could try to solve for y, or you can just make sure you don't have any y's with any even powers, and then it will be a function, okay? Sometimes, though, we're not given an equation or an ordered pair, we're just given a graph, right? And on a graph, anyone remember the vertical line test? Remember that from past algebra lives, okay? On the graph, the vertical line test is the easiest way to tell if it's a function or not. And how the vertical line test works is you want to draw a vertical line, and you want to think about drawing a vertical line on your function anywhere. And if at any point you draw a vertical line on your graph and it intersects more than one time, then it's not a function, okay? So for example, on this graph, if I draw a vertical line right here, it intersects the function 1, 2, 3 times, right? So that is not a function, Okay, and that can, if that happens any time at all on your function that intersects more than one time, then it's not a function. So this one is not a function. Whereas with this one right next to it, if I draw a vertical line anywhere, it's only going to ever intersect one time, right? If I draw a vertical line anywhere here, doesn't matter where I draw it, it's only going to ever intersect one time. So this passes the vertical line test and is a function. So you need to look for if you ever draw a vertical line and you intersect more than one time, then you are not a function. Because what you're doing here is you have one x value that now has multiple outputs, right? And so that's a repeat in the domain. So it's all tied to the same definition. It just looks different sometimes on graphs versus equations. So write down underneath each one of these whether you think it's a function or not a function. If you want to like abbreviate NF for not function and F for function, go ahead and write down under each of these four whether it's a function or not a function. All right, compare with your table what you wrote down for those four. All right, first one, what do you think? Function or not function? Not a function. If I draw a line right there, it goes through twice, so not a function. How about the second one? Function or not a function? Not a function. Anywhere you draw a line on there, it's going to go through it twice. How about the third one? Function. No matter where I draw a vertical line here, it's only going to pass through once. And the last one is also a function because no matter where I draw that line, it's going to pass through once. Okay, any questions about determining whether something is a function or not? Ringing some bells, at least a little bit? Okay. This part, we might run into a couple things that are a little bit newer. Okay, so if we have an equation for a function, this is function notation right here. This says f of x, okay? And then it tells us what depending on what x is, what happens to it. So in this case, we square x, we add 3 times x, and then we add 5, okay? So what you probably have done before is something like this. If I have f of 2, my x has now become what? 2. F of 2. Now my x is 2. So what do I do with all these x's here? What do they have to turn into? A 2, right? So when they put a 2 in there for x, that means every x has to be replaced with a 2. So now I'm going to replace every x there with a 2. So we'll have 2 squared. Then that's 3 times x. So 3 times 2. And then plus 5. So I'm just replacing every single x here with a 2. 2 squared is 4. 3 times 2 is 6. Plus 5, that'll give you 15. So f of 2 is 15. Do you remember evaluating functions like that? A little bit? Okay, so not bad with it's a number. B is where it gets a little tedious, okay? You may have done this before, you may not have. You have all the algebra skills to do it, okay? But it does have a couple steps. So this is probably where some of you might need the most practice, okay? So you might need to go try some of these problems at home tonight, okay? So now, inside this, I don't have a 2 anymore. What's inside? X plus 3. So what do I have to replace every single x up here with? X plus 3. I have to replace every single x up there with x plus 3. So to do f of x plus 3, I'm going to replace this x with x plus 3. So we'll have x plus 3. And then we're squaring that. So to say that I square the whole thing, I need to put parentheses around it. So I just took this x plus 3 and I put it in there for x, just like I took the 2 and put it in there for x. Then I've got plus 3. That's being multiplied by the x. And we are now putting x plus 3 in there for that x as well. And then there's no x with the 5, so we just get to add 5 on the end. Okay, so all we're doing, just like you put the 2 in here for each x, we're just putting what's inside where all the x's are. Okay, but we do need to multiply this out and simplify. Okay, this part you probably feel pretty good about, right? This part right here, we know what to do with here. Yeah, here we need to be careful. Okay, I promise you at least 50 people will make this mistake this year. You cannot do x squared plus 3 squared. Okay, I have a little meme about this and can't find it. I gotta find it and put it up in my room. This is not x squared plus 3 squared. Okay, you cannot do that. It doesn't work with addition to distribute the 2. That was only when we did it with multiplication. Okay, so what do we do here then? Well, what do we do when we square something? What is 3 squared? 9. How do we get that? 3 times 3. So when you square something, you multiply it by itself, right? So this is x plus 3 squared. So that's x plus 3 times x plus 3, right? You're multiplying it by itself. So this is x plus 3 times x plus 3. That's what it means to do x plus 3 squared. Then we still have our 3 times x plus 3 plus 5. Once we write it down this way and we remember that it's not x squared plus 3 squared, we have to multiply this. Remember multiplying stuff like this out? Anyone heard of FOIL? You might have heard that. Yeah, you can FOIL first, outside, inside, last. If you haven't heard of FOIL, you've probably heard about distributing, right? We have to multiply everything in here by everything in here. So, for example, I got to start with the x, and I need to multiply by x. X times x. What's x times x going to be? X squared. I also have to multiply the x by the 3, which will be 3x. So I multiplied x by everything in here, and then I have to do the same thing with the 3. I have to multiply the 3 by everything in here. So 3 times x is 3x. And then I have to do the 3 and the 3. So 3 times 3 is 9. That is probably one of the only algebra things we did not review in the first unit, was distributing like that. So if you need help remembering how to do that, come see me. And then over here, we remember we distribute the 3, right? That one's pretty easy to remember. 3 times x, 3 times 3. So we'll have another plus 3x, plus 9, and then we have our plus 5 on the end. Do we remember multiplying these things together like this at least a little bit? Okay. Am I done? Can I just leave it like this? No, I've got to simplify. I've got some like terms. X squared is the only x squared term, so it's just going to stay x squared. I've got 3x, and 3x. Those are all like terms. They can combine to be 9x. 3 plus 3 plus 3 is 9. And then I've got a bunch of numbers that are like terms that I can combine. 9 plus 9 plus 5, that is 23. And now I'm done because I cannot simplify that anymore. There are no more like terms. Any questions about any of those steps? These are the ones that I recommend practicing, especially if you need some more help with the algebra review. Okay, let's do one more. F of negative x. What am I going to do with this negative x? I'm going to plug it in there anywhere there is an x. So f of negative x will be negative x squared. Whenever you have a negative number, I recommend putting it in parentheses so you don't accidentally mix up. That's negative x squared plus 3 times negative x plus 5. When I square something, I'm multiplying by itself, so it'll be negative x times negative x. 3 times negative x will just be negative 3x, and we'll have our plus 5. And when I multiply a negative times a negative, I'm going to get a positive what? X squared. So this one was a little bit faster and a little bit easier. I put C and D on here if you want to practice those, but we're not going to do them together right now. Okay? Any questions from B and C? Okay, now let's talk about how we read a graph with functions, okay? Hopefully this is a little bit of a refresher, okay? But again, we just kind of want to make sure we remember some of the basics of functions. So when we had an equation, what did we do with this negative 2? What did we do with that negative 2 in the problem above when we had the equation? I don't know, I don't have an equation now, but what did we do when we had an equation? Yeah, we replaced it where? Where did we put it? For x, right? So this is an x value, right? It's inside, right? That means it's replacing the x. So that negative 2 is an x value. So on our graph, we don't have an equation to plug it into, so we need to figure out what is the output when we plug in negative 2 on the graph. We need to go over to negative 2 on the x-axis, and we need to see where my function is. It's right down here, right? So at negative 2, my function is right here. What's the y value at that point? Negative 4. So that's your y value. That's the other part of your ordered pair. That's your output, right? We did that with the equation above. Now we're just looking on a graph. So f of negative 2 will be negative 4 because the y value that goes with that x value is negative 4. To find f of 2, this is my x value. So I'm going to go over to the x-axis to 2. And I'm going to go down to where the function is at that point. When x is 2, what's the y value here? Still negative 4. So f of 2 is negative 4. Go ahead and try C, D, E, and F on your own. So go over to that x value and figure out what is the y value at that point. All right, so for f of 4, for C, we go over to x value 4. My function's up here. Y value is 4, right? So this is 4. At negative 4, for D, we go to the x value negative 4. My function's up here. Y value is 4 again. At f of negative 3, we're going to go to negative 3. Where's my function At -3. Well, it's crossing that point right there, right? It's just right where my finger is. So what's the y value there? 0. Right here, remember the y value is 0. So it crosses right there at -3. So this is 0. That's what we call an x-intercept. Remember that? And then at -1 for x, my function again, it's right here. It crosses right through there. So y is also 0 again. Any questions on any of those? Okay. Last thing that we're going to talk about, domain and range for a function like with an equation. So we did domain and range when we have the list, right? The list, you just list out all the x values and all the y values, okay? The problem with functions here is there are infinitely many points on here, right? So you cannot list out every single x value and every single y value, right? There's infinitely many. There's -2 point or -1.5, -0.5, right? And there's all the little decimals in between. So we have to describe our domain and range with intervals, okay? When we have an equation or when we have a graph, okay? We're going to stick to just graphs for now. We'll do domain and range for equations down the road and in a later unit. So we're just going to look at the graph. So remember, the domain is what? X or Y? Domain is X. Range is the Y. So for this function here, it starts here, ends up here. But we need to look at for the domain, we need to see where does the x value start and stop. So what is the first x value for this function? -2, right? If we start over here on the left, the function starts right here at -2. Then as we move along, the x values, it goes through like all these decimals, right? It goes through -1, it goes through 0 x values. And what's the last x value? Right here, it's at 1, right? Because then it stops, okay? So it goes all the way from -2 to 1. So this is why we talked about intervals the other day, because we need to describe this set with an interval. Every number from -2 to 1, we're going to include -2 and 1 because there's closed circles here at the ends. Okay, so we put the bracket on there. So this is every number between -2 and 1. We can't just say -2, -1, 0, and 1 because of all the decimals in between, right? We can't just list out the domain like we did with the problems at the beginning. And then for the range, we're just going to do the same thing, but for the y values, this way, right? So if I go down here, my function is right here. What's this first y value right here? What's my y value here? 0. We're starting right here at 0. And then my function goes up, 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 up. But its last y value is right here at 3, right? And then it stops. And there's no more y values. So this is going to be from 0 to 3, both included with brackets because they're closed circles at the ends. So try B on your own. Look at where the x values start and stop for the domain and where the y values start and stop for the range. So for B, if I'm looking at my x values, my function goes from here to here. So the first x value is at -2, and then it keeps going, and then the last x value is at 1. So this is -2 to 1. But then now I'm going to have a parentheses on the -2 because of that open circle, right? So that means it doesn't actually get to -2, right? It goes all the way up close to -2. And then at 1, there's a closed circle. So that will be a bracket. And then for the y values, if I go, where's the first y value? It's right here. So the y value starts at -1 and goes all the way up, but 2 is the last y value. So it's -1 to 2. At -1, it's a closed circle, so that will be a bracket. And then at 2, it's an open circle, so that'll be a parentheses. Any questions on B? All right, we're not going to do C because it's a little tricky, but I'll write down the answers in case you tried it and you wanted to know. That's the answers for C if you tried it and you wanted to know. But it's a little tricky, so we're not going to do that. All right, last one. We want to talk about one more situation here. Okay? So, last situation. We'll go over X and Y intercepts tomorrow real quick, but you should know what those are. Those should be pretty easy to remember. When sometimes a function goes off the page, I want you to write down this last one. I still got 2 minutes. Okay? I'll give you a minute to pack up. Here, when I look at my X values, this function keeps going forever off the page, right? It doesn't stop here at -2, right? So here, is there a starting X value? No, right? It's going to go all the way to what? -infinity. So the domain here will go from -infinity, and then I'm going to trace my function all the way. It's going to keep going this way and this way. So is there going to be an ending X value? Nope, so it's going to go all the way to +infinity. Because this function is going to keep going this direction and keep going up and up, so the X value will never stop, and the X value this way will stop. But with the Y values, does the function go all the way down here forever? No, where's the first Y value? -4, and it actually hits -4, so it should be a bracket. Okay? And then, but does it ever stop when we go up? No, so then it's going to go to infinity. Okay? So that's the last example I wanted you to see there. We'll refresh real quick on X and Y intercepts tomorrow and do some practice.